Welcome back, students. In our previous classes we have discussed about Newton's laws of motion. We have understood how these laws help us to get an understanding regarding force, that is the basic cause of all types of motion. Today we will be studying about an important conservation law. This is law of conservation of momentum. There are several conservation laws in physics. So, before understanding what is law of conservation of momentum, I would like to give you some idea regarding what are these conservation laws. In physics, a conservation law states that a particular measurable property of an isolated physical system does not change as the system evolves over time. What is an isolated physical system that I will be explaining shortly? You should understand right now that whenever we are finding the magnitude of any physical quantity means the value of which can be measured. So the magnitude of any physical quantity for an isolated physical system does not change with time. This means its magnitude remains constant over a period of time. It remains conserved over a period of time. Now, what are those physical quantities? These quantities are energy, linear momentum, angular momentum, and electric charge. Exact conservation laws include conservation of energy, conservation of linear momentum, conservation of angular momentum, and conservation of electric charge. There are also many approximate conservation laws that apply for quantities such as mass, parity, lepton number, baryon number, strangeness, hypercharge. These quantities are conserved in certain cases of physics but not in all, about which you will be studying in your senior classes if you opt for physics. But for the time being, we will be considering only the exact conservation laws, and in the syllabus of class 9, you will be studying about two of them, that is law of conservation of energy and law of conservation of linear momentum. Since in class 9 we have studied only about motion along a straight line, so whenever we are making use of the word momentum, you should remember that we are talking about linear momentum. When the object is rotating about an axis, then the momentum of the object is called angular momentum, but that you will be again studying in senior classes. So right now we will be focusing only on linear momentum. I hope you remember what is linear momentum, or more precisely momentum. It is a very important physical quantity because it helps us to understand the motion of a body or a system. We can very easily find out the momentum of a moving body using the formula momentum equal to mass multiplied by velocity. Symbolically, we can write down P equal to m into v. P is the momentum, m is the mass, and v is the velocity. This is the momentum of a single object. But what about the momentum of a system? When the word system is used, actually we are talking about more than one object. I would like to tell you that for a system, at least we need two objects. We can take help of the example given in this picture. Say we are considering the system of these two objects, one which is the moving car and one which is the target car. Let us label them as 1 and 2 and assume that this is the system. How to find out the momentum of this system of two objects? For this, we have to separately find out the momentum of both the objects and then find the sum. So let us assume that the mass of the first object is m1 and its velocity is v1. Mass of the second object is m2, its velocity is v2. Then what should be the momentum of the first object? It would be equal to m1 v1. What about the second object? The momentum will be m2 into v2. So when we are finding out the momentum of the system of these two objects, we have to simply add. We will be adding up the momentum of the individual objects. So this will give us the momentum of the system. So just see, when we are talking about the momentum of one object, we are using the formula mass into velocity. But for more than one object, separately we have to find out the momentum of every object and then add it up. This expression can be extended for any number of objects that is making up the system. So in this manner we can find out the momentum. I hope you also remember what is the SI unit for momentum. The SI unit is kg meter per second. So now we can understand what is law of conservation of momentum. The total momentum before a collision is equal to the total momentum after the collision if no external forces act on the system. What is a collision? Collision is an interaction taking place between two objects. So talking about a system, if we are considering the simplest situation where there are only two objects making up a system, if they are hitting each other, if they strike against each other, then that interaction will be referred to as a collision. Now what happens during a collision? During a collision, there is a force applied by one object on the other. Now we all know, whenever one object applies a force on the second object, the second object also applies an equal and opposite force on the first object. Due to these forces, there can be some change in state of both the objects. Change in state means change in velocity. The velocity may increase or decrease. If there is a change in velocity, there may be some change in momentum, or rather there will be some change in momentum. But as per this conservation law, the total momentum before the collision will be equal to the total momentum after the collision. The condition is that no external force should act on the system. The two objects who are a part of this system, they can interact with each other, they can apply some force on each other, but no external force is acting on the system. In this situation, total momentum will remain conserved. You should remember that the law of conservation of momentum holds good both for macroscopic and microscopic systems. This means it is true for all collisions between any objects, whether it is between a car and a truck, two railroad cars, a proton and a proton, or a planet and a meteor. It is applicable for all types of systems. Let us understand this in a much better way. The same law can be stated in a slightly different way as, in an isolated and closed system, the total momentum of the system remains constant in time. Now, again we have consider two systems as you can see in the picture, but we have tried to specify the qualities or characteristics of this system using two terms. What are these two terms? Isolated and closed. The system is an isolated and closed one. What is an isolated system? Isolated system is a system in which no external forces are acting. As you can see in the picture, both the objects can interact with each other, can apply force on each other, but no external forces are acting on this system. What is a closed system? In which no mass enters or leaves. The total mass remains the same. Now in the third sentence it is written, the linear momentum of each colliding body may change. Let us try to understand this statement. For this, let me assume that the first object is having a mass m1, second object is having a mass m2, the first object is having a velocity initially u1 and the second object is initially having a velocity u2. So what should be the momentum of the first object? It is m1 u1. What is the initial momentum of the second object? It is m2 u2. The total initial momentum can be obtained by adding up these two values. So this is the total initial momentum. Now the two objects interact, they collide against each other, apply some force on one another. Due to this collision, due to this interaction, there is a change in the state of the objects. So now let the velocity of the first object become v1 and that for the second object become v2. So now the momentum of the second object will be m2 v2. For the first object it will be m1 v1, and then similarly by adding we can find the total final momentum. Now let us see individually. What was the momentum of the first object before the collision? It was m1 u1. What happened to the value of momentum after the collision? It became m1 v1. There is a change. Let us see the second one. The second object was initially having a momentum m2 u2. Now it has become m2 v2. Again there is a change. So individually you can see that the momentum of both the object has changed. That is what is written in the third sentence. But let us check the total value. The total momentum. What was the total momentum initially? It was m1 u1 plus m2 u2, and finally it has become m1 v1 plus m2 v2. This will remain the same. This is actually stated in the last sentence. The total momentum of the system cannot change. This is actually the mathematical representation of the law of conservation of momentum, whereby you can see that two objects A and B having masses m1, m2, moving with velocities u1 and u2 respectively, they have a total momentum of m1 u1 plus m2 u2 initially. Once they collide with each other, they apply some force on each other so that the velocities of each object changes. Let it become v1 and v2 respectively, so that total momentum after collision is m1 v1 plus m2 v2. So as per the conservation laws, the total momentum after collision and total momentum before collision, they are equal. So we will try to prove this. For this, just refer to this picture. We are considering a system of two particles. Let us name these particles as 1 and 2. Let us name these particles as 1 and 2. Let us assume that the first particle is having a mass m1, second is having a mass m2. Initially the first object is moving with velocity u1, second is moving with velocity u2. Now both the objects collide. Let the collision last for a time t. The collision takes place for a time equal to t. During this collision, the first object applies a force equal to F1 on the second object. The second object applies a force equal to F2 on the first object. Now, due to the force, there will be some change in the velocity of the first object. Let it become v1. And similarly, there will be a change in the velocity of the second object. Let it become equal to v2. We will try to write down the expression for the force using Newton's second law of motion. We know from second law, force is equal to mass into acceleration. When first object is applying force on the second, that is F1, due to this force, there will be some acceleration in the second object. Similarly, when force F2 is applied by the second object on the first one, there will be some acceleration on the first object. Using this understanding, we can write down F1 equal to m2 v2 minus m2 u2 by t. Force applied by the first object on the second object will produce acceleration on the second. So we have written down F1 equal to m2 v2 minus m2 u2 by t. Similarly, when the second object applies force on the first object, there will be some acceleration in the first object. So we can write down F2 equal to m1 v1 minus m1 u1 by t. Now, we know from our understanding of Newton's third law that to every action there is an equal and opposite reaction. Now, isn't in this case F1 and F2 the action and reaction forces? So, by Newton's third law, we can write down to every action there is an equal and opposite reaction. So, the equal to sign has been put to signify the magnitude, and the negative sign, the minus sign, has been put to signify the direction. So, F1 is equal to minus F2. Let us substitute the expressions for F1 and F2. So, since F1 is equal to minus of F2, so we can write down equal to now we can cancel out t from both the sides. In the next step, we will try to remove the bracket. For that, we have to multiply both the terms with the negative sign. If we bring the terms having u in one side and the v terms on the other side, we get this is actually the desired result, whereby we have proved that total momentum before collision is equal to total momentum after collision. This is a very important proof and is asked quite often in the examination, so you should practice it properly. The law of conservation of momentum finds its use in many practical cases like recoiling of gun, collision of atoms in the game of snooker when a ball is hit by a stick, when the mouth of an inflated balloon is left open, it starts flying, when a cricket ball is hit by a bat, when the coins of carom board are hit by striker, or in Newton's cradle. They can all be understood with the help of the law of conservation of momentum. We will try to apply this law in some situations. Let us consider the situation of a dodgeball game. The ball is thrown at someone, the dodgeball is moving, obviously it has momentum while the person is not. The person is not moving, so he has no momentum. Once the dodgeball has hit the person, there is a collision, it will transfer some of its momentum to the person and the dodgeball has some left over. So, in order to keep total momentum conserved, some amount of momentum is transferred to the person while the remaining is with the ball. Why is it difficult to hold a hose pipe in its position? We had analyzed this situation using Newton's third law. Now, we can analyze the same situation using the law of conservation of momentum. When the system of hose and water is not ejecting any water, its momentum is 0. When the water issues out from the hose with a high velocity, it has momentum in the forward direction. Therefore, in order to conserve momentum, the hose tends to move in the backward direction. So, it becomes difficult for the fireman to hold the hose pipe properly in its position because it is moving in the backward direction with a huge velocity. The velocity with which water is being ejected outward in the forward direction, it has got huge momentum in the forward direction, so it applies a backward momentum, it gives a backward momentum to the pipe, due to which it starts moving backward. Why does a gun recoil? Initially, when the bullet is not fired from the gun, the total momentum of the system of bullet and gun is equal to 0. But just imagine once the bullet has been fired, the bullet has got tremendous velocity and obviously it has got very high momentum. So, to keep total momentum constant, the gun is given an equal momentum in the backward direction, due to which it recoils, due to which it moves through some distance in the backward direction. Now you can see that the situation has been shown very clearly in this picture, what happens before and after. Initially, the momentum, total momentum of the system of bullet and gun is equal to 0, while finally also it should remain equal to 0. Now once the bullet has been fired, what will happen? An equal momentum will be given to the gun, due to which it should recoil through some distance in the backward direction. So we can write down using the second expression, mass of bullet multiplied by velocity of a bullet is equal to mass of gun into velocity of gun with a negative sign. The negative sign is given because the gun will move in the opposite direction. Therefore, velocity of gun will be equal to mass of bullet divided by mass of gun multiplied by velocity of bullet. Obviously there will be a negative sign. Now since the mass of gun is extremely big as compared to the mass of bullet, so the velocity of recoil of the gun will be much smaller than the velocity of the bullet. This is an important formula for solving numerical questions. We can also apply this in understanding why a balloon moves forward when air rushes out of it in the backward direction. As the air comes out of the neck of the balloon, for momentum to be conserved, the balloon and remaining air must move in the opposite direction. This is what happens, and the balloon whizzes around the room, moving in the opposite direction to the airflow. The same principle can be applied in rocket propulsion. Rocket ejects gases in backward direction, which creates momentum of the gases backward, and thus by conservation of momentum the rocket gets a momentum in the forward direction, making it to move forward. Now we can understand how law of conservation of momentum can be understood with the help of Newton's cradle. You have already seen what is a Newton's cradle in the introduction part of this lesson. Let me show you the Newton's cradle again. So this is a Newton's cradle. How does it help in understanding law of conservation of momentum? Just observe this carefully. You can see that the number of balls moving on both the sides is exactly same. All these spherical balls are having same mass. When one ball is hitting the system, on the other side also one ball is moving. Let me explain this situation. You lift any number of balls and let go. The moving ball then collides with the stationary ball and causes an equal number of balls to move on the other side. This demonstrates conservation of momentum because the number of balls moving before the collision is equal to number of balls moving after the collision. Each ball has the same mass. So this is equivalent to saying the mass of moving balls remain constant from collision to collision. What about velocity? Well, the velocity of the moving balls right before the collision and the velocity of the moving balls on the other side right after the collision are equal. This can be seen because the moving balls after the collision will never surpass the starting height of the balls on pre-collision side. You might have observed that the height through which the first ball was moving on left hand side, the ball on the extreme right was moving through the same height after getting hit, after the collision has took place. So if mass and velocity are unchanging for the system right before and right after collision, then the momentum will necessarily be constant, hence conserved. So these were some of the examples through which we can very well understand law of conservation of momentum. Now I would like to introduce one term, impulse. Impulse is the amount of change in an object's momentum. How to define it? It is the product of the force applied to an object and the amount of time applied. SI unit for impulse is Newton second. So we have an impulse momentum theorem. The change in momentum depends on the force that acts and the length of time it acts. Symbolically, we can write down impulse equal to final momentum minus initial momentum. When a net force acts on an object, the impulse of the net force is equal to the change in momentum of the object. From the word impulse, we get a term called impulsive force. An impulsive force is a very great force acting for a very short time on a body, so that the change in the position of the body during the time the force acts on it may be neglected. A very short time, a very short duration, the force is acting on the object, but it can produce a very large change in its momentum. The impulsive force is much stronger than any other force available at that point of time. So we can discuss some examples, like large force that acts over a short period of time during collision or explosion also can be defined as the rate of change of momentum in a collision or an explosion. So examples are of impulsive force are football, playing golf, playing baseball, playing tennis, playing badminton, where the time of contact between the two objects is very small, say a couple of seconds or a fraction of a second. Just imagine a batsman playing a sixer shot. What happens? The time of contact between the bat and the ball is so small, but still there is such a huge change in the momentum of the ball. That force is an impulsive force. I would like to explain what is the difference between impulse and impulsive force. Impulse of a force is the force multiplied by the duration of time for which it acts. In other words, it is the change of momentum the force causes in any body. However, impulsive force is a big force acting for a short time, like the stroke of a hammer or a one-time push given by a railway engine to a coach. So you should never be confused between these two terms. This was all regarding today's lesson. Go through all the topics that has been discussed up till now, right from the definition of force, balanced and unbalanced force, first, second and third law of motion, law of conservation of momentum, its proof, and all the reasoning questions that we have discussed regarding the different laws up till now. Go through this entire lesson and read every single topic properly to have a better understanding. Thank you.